baseline level of trust you just implicitly accept.
Oh, absolutely.
Like, you trust that the floor is going to firmly push back against your feet. You trust that the empty space between you and the wall is just that.
Yeah.
Empty, vacant room to move.
Right. It's just room.
And you trust that the clock ticking on the wall is actually measuring something.
Right.
A steady, real flow of time moving forward.
Yeah, I mean, it's the essential architecture of everyday life. If we didn't rely on reality being absolute or solid and sequential, we just wouldn't be able to function at all.
Exactly. But then I look at this massive stack of transcripts and papers you've sent us for today's deep dive. We're talking Brian Cox, Neil Turok, Speen Hossenfelder, plus these really deep theoretical papers on quantum entanglement and even this intense theological debate on the nature of gravity.
It's a lot of reading, I know.
It is. And I've been poring over these, and honestly, suddenly that entire house we live in feels like it's built on a complete mirage.
It really is a complete dismantling of classical reality. What these physicists and thinkers are revealing is that almost everything we intuitively feel about the universe, like, distance, time, weight, emptiness, it's fundamentally a biological illusion.
And that is exactly our mission today. We are going to systematically dismantle everything you thought you knew about reality, starting with the very concept of nothing, and we're going to rebuild it using the absolute cutting edge of theoretical physics. So, okay, let's unpack this.
Yeah, to really understand reality, we have to start at the absolute beginning. Or, I guess, more accurately, we have to look at the canvas on which the universe is painted. Human intuition assumes that if you take away all the stuff, you are left with an empty void. Just a whole lot of nothing.
Right, and there's that incredible anecdote about William Shatner and these materials. He finally goes to space at 90 years old.
Oh, yeah, that story is wild.
Right. And you'd think, as Captain Kirk, he's expecting to see this majestic grand tapestry of the cosmos, this beautiful ballet of galaxies. But when he actually looks out the window, he's terrified. He described it as witnessing a cold, dark, black void of death. He genuinely thought he was looking into true, absolute nothingness.
It's a profound human reaction, definitely. But what's fascinating here is the underlying physics. Because Shatner wasn't actually looking at a void at all. As Brian Cox explains in his lectures, absolute nothingness is a physical impossibility.
With physical impossibility.
Yeah. To help visualize this, the physicist David Tong uses a brilliant analogy. He says we have to stop thinking of empty space as an empty box. Instead, we should think of it as a room filled to the brim with an invisible, incredibly dense fluid, something like molasses.
And that molasses is the Higgs field, right?
Yes. But it's not just the Higgs. Even if you could, magically remove all the stars, sweep away all the planets, block out all the radiation, and somehow turn off gravity entirely, you still wouldn't have nothing. The vacuum of space is governed by quantum fields.
Right.
And at its absolute lowest energy state, this vacuum is literally boiling.
Wait, boiling. Hold on. If there's no heat, and no matter what is physically boiling.
Energy. It's dictated by Heisenberg's uncertainty principle. You can never have exactly zero energy in a quantum field. So the vacuum is teeming with what we call virtual particles.
Virtual particles, okay.
Yeah, they are constantly borrowing a tiny bit of energy from the vacuum, popping into existence for a fraction of a second, and then immediately annihilating each other to pay the energy back. This is 0-point energy, and
Wow.
it never stops.
So if I'm looking at an empty coffee cup on my desk, it's not actually empty. It's more like looking at a seemingly calm ocean surface. But underneath, on a microscopic level, it's a frantic, boiling mosh pit of quantum energy popping in and out of reality.
That is the perfect way to picture it. The void is alive. Now, if the universe didn't come from a quiet, empty nothing, how exactly did it start? The standard textbook answer you and I learned is the Big Bang, followed by cosmic inflation.
Right, Alan Gough's theory from 1980. The idea was that the early universe expanded exponentially fast for a fraction of a second. It basically smoothed everything out, which solved some massive headaches for physicists, like why the universe looks so perfectly flat and why the background temperature is uniform everywhere we look.
It was a brilliant fix at the time, but it introduced a new, arguably terrifying mathematical consequence. The math of inflation suggests that once it starts, it's incredibly hard to stop it entirely.
Ah, right.
Which leads to the concept of eternal inflation. In this model, inflation stops in our little pocket of the universe, which causes our specific Big Bang, but it continues expanding forever everywhere else. It generates a fractal multiverse with an incomprehensible number of pocket universes.
That's just so much to wrap your head around.
It is. Some string theorists estimate there are 10 to the power of 500 mathematically valid variations of our universe out there.
Which is just a chaotic, deeply messy picture. It feels like physics just threw its hands in the air. And this is where physicist Neil Turok comes in with a massive pushback. I have to say, reading his perspective was incredibly refreshing because he takes such a minimalist approach.
Turok's argument is highly compelling. He points out that theoretical particle physics has essentially been stuck in a rut since the 1970s. Every time a new observation didn't quite fit the math, the standard response was just to invent a new invisible particle to fix it.
Just kind of patching the holes.
Exactly. Or, in the case of string theory, invent 11 invisible dimensions. Turok argues we need to stop adding ad hoc imaginary stuff and start deeply trusting the fundamental symmetries of the laws we already know.
And his alternative to the multiverse bubble bath is this radical idea called the mirror universe.
Yes. In Turok's model, the Big Bang was not a messy singularity where all mathematical laws break down and explode into infinite multiverses. Instead, the Big Bang was an analytic, non-singular mirror. Time doesn't start at the Big Bang. It extends backward before it, into a perfectly inverted universe.
Hold on, time running backward. Are we talking about like Benjamin Button physics where breaking teacups assemble themselves?
Well, not from their perspective. It's a concept called CPT symmetry. C stands for charge, P for parity, and T for time. Turok suggests that if you mirror all three, meaning antimatter replaces matter, left and right are flipped, and time runs backward, the fundamental laws of physics work exactly the same.
So instead of an ever-expanding multiverse, Turok is saying the universe is shaped more like an hourglass.
Yes, that's a good visual.
The Big Bang is just the perfectly smooth, narrow neck in the middle. We live in the top bulb moving forward, and there's a mirror anti-universe in the bottom bulb moving backward.
Exactly. And the mathematical elegance of this is stunning. To make this work without inventing new particles, Turok introduces exactly 36 dimension zero fields. Now, to demystify that jargon, these aren't physical dimensions like up or down.
Right, they're not places.
No, they are mathematical degrees of freedom, basically internal dials that can rotate without taking up space. By adding exactly 36 of these dials, the math perfectly cancels out that infinite boiling vacuum energy we talked about earlier.
But a mathematical angle can just cancel out physical boiling energy.
In quantum field theory, yes, because those zero-point energies can be positive or negative depending on the type of field. Turok's 36 fields perfectly balance the ledger to zero. Even better, his math naturally accounts for dark matter.
Oh, wow.
Yeah, it identifies dark matter simply as a highly stable right-handed neutrino. We already know left-handed neutrinos exist in the standard model. It's just perfect symmetrical bookkeeping.
Here's where it gets really interesting. If the timeline of our universe is fundamentally symmetrical, an hourglass instead of a straight arrow, what does that mean for the physical space separating you and me right now?
This is where we break classical physics entirely, because if we look at the quantum mechanical research in your stack of reading, physical distance might just be a macroscopic illusion. Space itself isn't fundamental.
Let's break that down, because this traces back to quantum entanglement, which was famously something Einstein absolutely hated. He called it spooky action at a distance.
He really did not like it.
No. He thought that if two particles were separated by 1,000,000 light years, they couldn't possibly affect each other instantly. Nothing moves faster than light. So he assumed they must just be carrying some hidden internal script, like a pair of gloves in two different boxes. If you open one and find a left glove, you instantly know the other is a right glove, but no actual information traveled between them.
It was a comforting thought, but the physicist John Bell came along and developed a mathematical theorem proving Einstein was wrong, and subsequent Nobel Prize-winning experiments confirmed it. There are no hidden variables.
Wow.
If you have two entangled particles and you separate them across the cosmos, the exact fraction of a second you measure one, the other instantaneously assumes the opposite state. Zero time elapses.
So they aren't sending a signal to each other through the physical space between them.
Right, they're correlating directly, entirely bypassing the physical space. Which leads physicists to ask, if particles can ignore distance, does distance actually exist at the fundamental level?
Okay, wait. Is physics saying we are literally inside a computer simulation like the Matrix? Is the distance between me and my microphone just a rendered optical illusion?
It's more profound than a Silicon Valley computer simulation. It's a concept called the holographic principle. It started with Jacob Beaconstein and Stephen Hawking, who realized something bizarre about black holes. All the 3D information swallowed by a black hole is perfectly mathematically encoded on its 2D outer surface, the event horizon.
Just on the surface itself.
Exactly. Then, physicist Juan Maldacena expanded this to the entire cosmos with his AD-SCFT correspondence.
Okay, add SCFT. That's a massive piece of jargon.
Fair enough, let's simplify it. Imagine a soup can. AD-S, or anti-de Sitter space, is the 3D soup inside the can where gravity exists. CFT, conformal field theory, is the 2D label on the outside of the can where quantum mechanics operates without gravity.
Okay, I'm with you.
Maldacena proved that the math on the 2D label perfectly describes everything happening in the 3D soup.
So the idea is that the source code of our entire 3D reality, you, me, the stars, the literal space between us, is mathematically written on a lower dimensional surface. Just like a flat 2D security hologram on a credit card projects a fully real 3D image when light hits it. We are the projection.
Precisely. And this is formalized by something called the Ryuta-Keyanagi formula, which explicitly maps how 3D space emerges directly from the amount of quantum entanglement on that 2D boundary.
That is wild.
In this framework, distance and gravity aren't fundamental ingredients of the universe. They are emergent properties. Space is essentially a quantum error-correcting code. The entanglement weaves the fabric of space together to protect the fundamental information.
My brain is officially melting. If 3D space is just an emergent projection, a byproduct of entanglement, surely time is still real.
Yeah.
I mean, I vividly remember yesterday my coffee is currently getting cold because entropy increases. We experience time flowing forward.
It feels incredibly real. But let's look at Einstein's block universe. Relativity shows us that time is entirely relative to speed and gravity. If you and I are walking down the street in opposite directions, our slices of the present tilt differently across the universe. Your right now might include a supernova in the Andromeda Galaxy that won't happen in my right now for another 3 days.
Wait, so my future is already your correct?
Exactly. The only way the math of relativity works without paradoxes is if the past, present, and future all exist simultaneously as a rigid, unchanging geometry.
But if time doesn't flow, why am I aging? Why do I feel like I'm moving through it while we record this?
Think of it like a DVD. The plastic disc itself doesn't change. The entire movie is burned onto it at once. The beginning, the middle, the climax, they all exist simultaneously in the physical structure of the disc. Your consciousness is just the laser reading the data sequentially.
That is just, so it's hard to process.
And it gets even more static. When physicists Bryce DeWitt and John Archibald Wheeler tried to combine quantum mechanics and gravity to describe the entire universe at once, they created the Wheeler-DeWitt equation. But when they ran the math, the time derivative, the variable that dictates change, equaled exactly zero.
Zero, meaning no change.
Right. At the absolute fundamental level, the universe is perfectly frozen. Nothing changes.
So where does the ticking clock on my wall come from? If the universe is frozen, why do we experience change?
From our own ignorance, actually. This is known as the thermal time hypothesis, proposed by physicists Page and Wooters. Time is just a statistical illusion generated by our limited perspective. Because we are massive, localized biological systems inside the universe, we can only perceive a tiny, blurred fraction of the total quantum data.
Like we can't see the whole DVD.
Exactly. We just see the single frame our laser is on. That blurring, the friction of interacting with entangled subsystems is what we biologically translate as the flow of time.
So if I'm tracking this, we've stripped away the empty vacuum and filled it with boiling energy. We've mirrored the Big Bang to balance the universe. We've flattened 3D space into a 2D hologram, and we've completely frozen the arrow of time. The only thing left in the room that feels truly grounded is gravity. It's the force pulling us down to Earth right now.
Except Sabine Hossenfelder's insights upend that too. Gravity is not a force.
Right. She gives this incredible example that broke my brain for a minute. She says, if you place an accelerometer, a device that measures physical acceleration on a table, it doesn't read zero. It registers an upward acceleration of 9.8 meters per second squared.
Yes, and that's because there is no invisible gravitational rope pulling the accelerometer down. What is actually happening is that the electromagnetic bonds of the floor are physically pushing up against the device. If you were to jump out of an airplane in true freefall, an accelerometer in your pocket would read zero.
Because in freefall, nothing is pushing against you.
Exactly. Einstein realized that gravity is simply the geometry of space-time telling mass how to move. In a curved space-time, objects just naturally want to follow the straightest possible path, which is called a geodesic.
Okay, a geodesic.
The only reason you and I feel weight right now is because the atomic structure of the Earth is exerting internal pressure to push back against our natural path. If you miraculously removed the Earth's internal electromagnetic pressure, the planet wouldn't just sit there. It would instantly collapse into a black hole about 3 millimeters across, just freely following the inward curvature of space.
Which leads us to a really fascinating detour in the materials. Because gravity is invisible, omnipresent, and essentially sustains cosmic order by curving reality itself, some theologians have started asking a very provocative question. Is gravity structurally analogous to God?
It's a profound question that sits right at the boundary of physics and metaphysics, and we should be very clear here. We are not taking sides or endorsing a religious view, but simply unpacking the fascinating debate these thinkers are having in the sources.
Absolutely. We're just looking how they frame it. The PRO side points to ancient texts. Job 26.7 literally says God suspends Earth over nothing, which feels like an eerie premonition of gravitational orbits.
Right, it's very evocative.
And you have medieval mystics like Meister Eckhart describing God not as a person, but as a pulling force drawing all things toward unity. And practically, they invoke Occam's razor. If God and gravity share all these functional properties, omnipresent, invisible, sustaining, uncaused, maybe they're two different vocabularies for the exact same thing.
It's an elegant thought, but then you look at the con side, which forcefully argues that equating the two strips theology of all its actual meaning, gravity is purely impersonal. A murderer and a martyr thrown off a cliff both fall at the exact same 9.8 meters per second squared.
Right, there's no moral judgment there.
Exactly. Gravity cannot show mercy, it cannot forgive, and it cannot create something out of nothing.
Not to mention the problem of evil. If gravity is literally the direct active will of God, then God is directly responsible for deadly tsunamis, avalanches, and asteroid impacts. So what does this all mean? One of the philosophers in the reading points out that this is a classic category error.
Oh, the university analogy?
Yeah, and it feels like calling God gravity is like walking around a beautiful college campus, looking at the brick buildings, the library, the dorms, and asking, yes, but where is the university? You're confusing physical structures with a metaphysical concept.
I agree with that assessment. Conflating them is scientifically redundant and theologically limiting. Physics explains gravity perfectly well without theology, and theology explores God without needing a physical equation.
Right.
But if we step back from the debate, there is something profound here. The sheer awe of what we call the Einsteinian sublime, the realization of how deeply beautiful, elegant, and interconnected the curving of space-time is, serves as an incredible meeting point. It's a place where mystics and physicists can stand together, looking at the same equations, and share a genuine sense of wonder.
Okay, so let's pull all of this together, from the metaphysical right back to the ultimate physical fate. If the universe is a timeless holographic block, how does this story actually end?
Well, according to standard cosmology, we are headed for the heat death, or the dark era. Trillions of years from now, the last stars will burn out. Then, the supermassive black holes will slowly evaporate via Hawking radiation.
Just slowly dissolving over eons?
Exactly. Eventually, even the protons that make up the remaining atoms will decay. You are left with a cold, infinitely expanded gas of photons. Absolute maximum entropy.
Which sounds incredibly bleak, just a cold, dark, infinite soup. But then the source material introduces Sir Roger Penrose and his theory of conformal cyclic cosmology, and he flips this bleak ending completely on its head.
He does because of a brilliant insight into the nature of photons. Photons, particles of light, have absolutely no mass. And according to relativity, if you have no mass and travel at the speed of light, you do not experience time, and you do not possess a sense of physical scale or distance.
Wait, so to a photon, the universe doesn't have a size?
Exactly. Without mass, the universe loses its ruler and its clock. Penrose realized that mathematically, an infinitely large, infinitely cold, massless universe forgets how big it is. The geometry scales seamlessly. That infinite cold void becomes mathematically identical to an infinitely small, infinitely hot singularity.
So the end is the new Big Bang. The universe loops seamlessly back into itself.
Yes, and this ties perfectly into the work of John Archibald Wheeler. He coined the famous phrase, it from bit, proposing what he called the participatory universe.
The participatory universe.
Yeah. Wheeler argued that the universe does not have definite resolved properties until information is actively registered by a physical system. Observation, not necessarily conscious human observation, but physical quantum registration is what forces the universe to lock in its history.
So in a very real sense, the universe bootstraps itself into existence. It requires observation and interaction to make itself real.
Exactly. The universe is fundamentally a self-referential information structure.
Okay, we have covered an immense amount of ground today. For everyone listening, in just one deep dive, we've taken the empty vacuum of space and filled it with a boiling ocean of quantum energy. We've mirrored the Big Bang to balance the scales of time.
It's quite a journey.
It really is. We've flattened 3D distance into a 2D holographic projection. We've frozen the arrow of time into a static DVD. We've exposed gravity as a geometric illusion rather than a pulling force. And we've looped the cold, absolute death of the universe seamlessly back into its fiery birth.
It is a profound, total shift in how we perceive our existence.
It really is. And before we go, I want to leave you with one final mind-bending concept derived from the quantum theories we explored today. Specifically, Frank Tipler's idea of the omega point and the simulation hypothesis.
Oh, this is the ultimate logical conclusion if we accept that the universe is just an information processor?
Right. Think about this. If the universe is ultimately a massive quantum computer, and if, at the very end of time, a supreme, superintelligent, whatever that might be, uses all the remaining energy of the cosmos to perfectly simulate the entire history of the universe just to archive it.
Just running the whole program one last time.
Yes. How do you know you are living in the original physical universe right now? What if the life you are experiencing today, this deep dive you are listening to right now, is actually that final retrospective simulation happening in the very last microsecond of a dying cosmos?
It's a question that completely dissolves the boundary between physics and philosophy.
It really does. So the next time you walk into a room and you feel that comforting trust that the floor will push back against your feet and the clock will keep ticking forward, just remember, the architecture of reality is far stranger, far more fragile, and deeply more beautiful than a simple solid house. Keep looking up, keep asking questions, and keep exploring. Thanks for bringing us this stack of mind-expanding concepts. We'll see you on the next deep dive.